Hello there. In this video we're going to go over a couple examples of multiplying together polynomials. For this first problem, you have a whole bunch of linear terms that are being multiplied together, and you can actually group these however you want. So you might want to scan through and see if there's some strategic way of grouping them, like an x minus 2 and then later on an x plus 2, but there don't appear to be, so we might as well do this one left to right. We'll multiply these two first. So gathering those middle terms, we get the minus x, and then we multiply by x plus 5. Now for doing this kind of stuff, because it's not a quadratic or a linear term times a linear term, we have three terms here that are being multiplied over here. So I can't do first, outer, inner, last, because that completely ignores this middle guy. So I like having a strategy where I take the first term and apply it to each of them. So I'll multiply through there. That's going to get me x cubed plus 5x squared. And then I go to the next term. So remember that this is a negative x, so negative x times x, that's going to be minus x squared. And then we're going to have minus 5x, and then we get the last two. That's going to be minus 2x and then minus 10. Okay, so gathering our like terms in this one, we have like terms in a couple different places. One of them is going to be here with x squareds, and another one's going to be here with just x's. And we get this, and if I have a calculator, what we could do is we could go in and plug in the original one into y1, this one into y2, check a table to see that it's producing the same values. Could also just plug in some numbers, like if I stick in a 0, I'm going to get negative 2 times 1 times 5, that's negative 10. Y-intercept here is negative 10. So you can verify it in a couple different ways. Now, this way of doing it, I don't necessarily like continuing to do that as it gets larger and larger, so I'm going to show another strategy over here. You're starting left to right, and I'm going to go with the x squared, so that gets distributed to each and every term, and I'm going to write that over on the left. Now I'm writing this one a little bit funny, because notice that, so when I got that, I got x to the 5th, here's 2x to the 4th, but here I'm getting minus 3x squared. It's skipping a term, it's skipping the x cubed. So I'm like leaving a space there for x cubes. Now I go to the next one, and I'm going to write those products, not continuing over to the right like we did here, but actually beneath these, trying to match up like terms. So the negative 2 gets distributed through everywhere. And when I do that, I get minus 2x to the 4th. Here it's going to be minus 4x cubed, and I'm sticking that beneath this empty space, so I kept a placeholder there for x cubes. And the last one's going to be negative plus 6x, and I'm doing that out here, not directly beneath the x squared. Then I'm done with that one, so boom, boom, on to the last. Distribute through there, I get 3x cubed. Put that beneath my x cubes, then I'm going to get plus 6x squared, and at the very end a minus 9. And the whole point of doing this is that they're basically stacked up with like terms, and I can just go down the order here and count it. How many x to the 5th do I have? 1, x to the 5th. Here, these two cancel each other out. That's nice. Then I'm going to have minus x cubed plus 3x squared plus 6x minus 9. And when all is said and done, that's what we have. And you could, if you have access to a calculator, you can type that into a table, that and that, see that in y1, see that that's equal to y2 over here, or you could just plug in a few points to verify it too. Yep, thanks for watching. Character and Scholarship for Life.